Hello grade 11s and 12s. Welcome to another one of my videos. On today's video, this one is going to be slightly different because we will not be going through a past exam paper or a past exam question. Rather, I want us to have a look at the nature of roots as per your request. So please grab a seat, get your calculator, get your paper, and take as much notes as you have to. So what do we mean when we say the nature of roots, or what are the nature of roots? So first thing that I'm going to highlight is that the nature of root, it has to do with the graph of a parabola. Firstly, meaning when we talk about the nature of roots, we are referring to somehow something on the parabola, and also it has to do with a quadratic equation or a quadratic formula, because guys, you know, a parabola has a quadratic formula. So those are the two things that we relate the nature of roots to: a parabola and a quadratic formula. So when we say the nature of roots on a parabola, we are saying, okay, the roots of a parabola is the x-intercept. So the nature of roots is how is the parabola graph interacting with the x-axis. Okay, so if I give just an example of like just a typical graph of a parabola, and it's a positive graph, it's supposed to look nicer than this. So it's a positive graph that has its x-intercepts there and there. Okay, so when we say the roots of a graph, we are talking about the x-intercepts. So those two red points there, or the red dots, they represent the roots of a parabola. So we have different types of roots, and the first thing that I'm going to do, I'm going to state the different types of roots and show you how you can tell those roots by just observing a graph. And then later on the video, I'm going to show you how to use the discriminant, meaning now the quadratic part of the parabola, to determine the nature of the roots. I hope you are still with me, guys, over here. So the types of roots, so I'm just gonna say the nature of roots. The first category would be your non-real, and okay, non-real, and then the second category would be real. Real roots. Okay, so when we say something is non-real in maths, we mean it doesn't exist, it's not there, it's just imaginary, we don't have it. So when we say the nature of roots are non-real, we simply mean the graph does not interact with the x-axis. Okay, so non-real means the graph does not interact with the x-axis. So also I'm just gonna keep it there for now. And then on real roots, we are saying, okay, real roots, the graph does intersect with the x-axis, and it can intersect with the x-axis differently. So it can intersect with the x-axis just once, and then this one we call equal real roots. Equal real roots. Or it can intersect with the x-intercept, the x-axis I meant, twice, and these ones are unequal real roots. Okay, so now we are keeping it at that. We can have non-real roots, we can have real roots. Non-real, it means there's no intersection, or there's no interaction between the graph and the x-axis, between the graph and the x-axis. And the graph, guys, remember, I am referring to a parabola and x-axis. And then real roots, we have equal real roots, meaning the graph is only touching the x-axis once. Unequal real roots, the graph is touching the x-axis twice. So the next thing that I'm going to do, I'm going to draw the graphs. I'm going to draw a graph that shows non-real roots. I'm going to draw a graph that shows equal real roots and also unequal real roots. So starting with non-real, if a graph has non-real roots, it would look something like this. So it can be any type of a graph. It can be positive or negative as long as it's not touching the x-axis. So something like that. You can have a graph that looks like that, or you can have a graph that's a negative graph and it looks like that. Okay, my graphs don't look very nice, but they are parabolic. They are parabola guys anyway. So you see between the turning point and the x-axis there's a gap. Same there, between the maximum and its x-axis there's a gap. The graph never touches the x-axis line. So the x-axis line, we are referring to this line, guys. So that's non-real. We don't have any real roots. These are not the only two graphs that represents non-real. I mean, it can be any form of a graph. You can have the graph there, you can have the graph there. As long as it's not touching the x-axis, then it is having non-real roots. And the next thing that we will look at is real roots. So under real roots, we will start with equal. So we have firstly equal real roots. So when you say the roots of a graph are equal, we mean the graph is only touching the x-axis once. So if you have a graph that looks like that, the turning point is just sitting right at that the graph. So it's just touching the x-axis with its turning point. It can also be a negative graph that looks something like that, and it can come in different forms. That is also equal real root. That is also equal real root. So as long as it's touching the x-axis with just the turning point, then it is equal real roots. And then the second one that I'm going to highlight is your unequal real roots. So for unequal real roots, the graph is touching the x-axis twice. So this one is the one that we normally come across when we write tests and exams. It's always there, it's touching the x-axis twice. So you check there, 2 x-intercepts. If you check there, 2 x-intercepts. Okay, yeah, that's our unequal real roots. So the graph interact with the x-axis twice. Okay, so that's how, guys, you can tell the nature of roots by just observing a graph without doing any calculations. So the next thing that I'm going to introduce now is the quadratic formula, because on the quadratic formula we make use of the discriminant to determine the nature of roots. Quadratic formula. So we know, guys, the quadratic formula, yes, you don't have to know it by head. We do have it on the answer sheet, the formula sheet, I mean. So it's the one that states that x equals to plus or minus a square root of b squared minus 4ac, all divided by 2 times a. Okay, that is the quadratic formula. And then on the quadratic formula we have something that we call the discriminant. And the discriminant, we also give it the symbol delta. So meaning whenever I say delta is less than, delta is greater than, I'm referring to the discriminant. So we go on to say on the discriminant, delta equals to b squared minus 4ac. This is the second method that we use to determine the nature of roots. So we have different ways in which we can tell if we can tell the nature of root from delta. So I have made use of this classification there. Then I'm going to use the second one. It's similar to the first one that we did. It's exactly the same as the first one that we did. I'm just gonna add a few more things. So you can have delta to be negative. So let me say, okay, when delta is less than 0, then that's where we have non-real roots. And then you can have delta to be greater than or equals to 0, and here we have real roots. So real roots, delta is greater than or equal to 0, meaning b squared minus 4ac, that part over there, it's greater than or equals to 0. However, we can further branch out this one. Delta can be equals to 0, and for this one we have real equal, and then delta can be greater than 0, and that is real unequal. Still on real and unequal. So real equal, we are done. We will further branch this one. You can have real roots that are unequal, however they can be rational or irrational. Rational or irrational. So for rational, it's when your delta is a perfect square. Guys, you know perfect squares. In simple terms, when I have to explain what a perfect square is, I would say it's any number that when you put inside of a square root, you get a whole number. You get, yeah, a whole number, like your 4, your 9, your 16, your 1, your 36, your 64, your 81, your 100. So those are perfect squares. So if you calculate delta and you find out that it's a perfect square, it means you are working with real unequal rational numbers. And then your irrational numbers, it's anything else that when you put inside of a square root, it does not give you a whole number, like square root of 3, like a 3. If you get your delta as 3, square root of 3, it's a decimal, so it's irrational. So if it's irrational, it means delta, it's not a perfect square. Okay, so that's just the few things that I'm just gonna add on our branching. So you need to guys know this classification of your delta. So remember, we are saying that delta is, I'm just gonna switch back to my black pen and just log that part over there. Delta is b squared minus 4ac, meaning on your equation ax squared plus bx plus c, you are just going to extract your a, it will go over there, your b will go over there, your c goes over there. So just always know, guys, because they always bring these questions in different forms. On any quadratic equation, and any coefficient of x to the power of 2 would be your a. Any coefficient of just x to the power of 1 or just x would be b, and the constant, the number that does not have x on itself or next to it, it will be your c. Because they bring these questions and they now scatter it around so that you are now unable to identify your a, your b, and your c. So just know a must go with an x squared, b must go with just an x, and c doesn't have any x attached to it. Okay, so guys, this is how we do classification of the nature of roots. I'm going to do another video where I do the different types of questions that we can come across on the nature of roots. For so long, guys, please do subscribe on my YouTube channel, which is now attached on there on the comment section, where you will be able to get notifications on when I post the second video of every video that I'll be posting. But most importantly for now, the second video, or the second part of this video, which is now examples on how to answer the nature of root questions. Thank you so much for tuning on to my videos. I shall see you on the next one. Bye bye.